Today we will discuss about the moving coil galvanometer. What is moving coil galvanometer and what are the parts of the moving coil galvanometer? Firstly, we have a base with leveling screws and a frame in which our moving coil galvanometer will work. We have a north pole and a south pole magnet with a rectangular coil inside the north pole and south pole. We have a torsion head on the upper portion of the frame, terminal 1 on the left side and terminal 2 on the right hand side. This torsion head is connected to the rectangular coil and also this is connected to the terminal 1. Rectangular coil is connected with the elastic spring and this elastic spring is connected to the terminal 2. There we have a soft iron core in between the rectangular coil for providing radial magnetic flux from the north pole and south pole magnet. So these are the parts of the moving coil galvanometer. Now we will discuss about the working of the moving coil galvanometer. What will happen? There is a mirror for observing the coil rotation. Now north pole and south pole magnet will give magnetic flux which will produce rotation effect in the rectangular coil, and this rectangular coil is attached with the spring which will also rotate to some extent. Then this is connected with the terminal T2 and coil upper portion is connected to the terminal T1. The angle of the coil rotation we will measure how much the angle coil will rotate, and this angle will be proportional to the current flowing in the circuit. So from the angle of the coil rotation we can measure the current flowing in the circuit, and this spring will help to restoring the coil position back. As the coil rotate, it will restore it again and again, and we can measure angle of the coil for measuring the current in the circuit. So this is the moving coil galvanometer. Terminal T2 and terminal T1 will also be connected to the galvanometer for direct reading. So this is the working of moving coil galvanometer. By measuring the angle of the coil rotation, we can measure the current in the circuit. Thank you.